Hello, fellow speech scientists, and welcome to my presentation on the source filter theory, a description of the production of sound. I chose the vowel sound production for this presentation. How is the vowel sound created? Production of voice is based on the coordination of three factors: breathing, phonation, and resonance. Breathing air out of the lungs produces the power supply for the voice. This airflow from the lungs makes the vocal folds, or vocal cords, in the larynx vibrate to make the basic sound of the voice. This process is known as phonation. The source of the sound then travels from the larynx through the pharyngeal, oral, and nasal cavities before it is transmitted through the air. During this process, the source sound is being transformed according to the characteristics of the vocal tract system. This transformation can be thought of as a filtering process that receives the source sound and alters it by amplifying certain parts of its frequency related to the sound content. The frequencies that are amplified are known as resonances, or resonant frequencies of the vocal tract. Specifically, when applied to vowel production, the speech signal could be thought of as the result of the source signal from the glottis, produced by the glottis, and the resonator or vocal tract filter, known as the filters or formants, F1 and F2. The formants, the resonance frequencies of the vocal tract, are called formants. Designated as F1, F2, F3, etc., in ascending order, they can be displayed as spectral peaks in the frequency response of the vocal tract filter. If you look to the graphs to the right in the center, there are a few peaks as you notice the frequency and gain. These demonstrate the F1 and F2 frequencies. The vocal tract has 4 or 5 important formants that are used to amplify certain frequencies. What we need to remember about formants, primarily in vowel production, are F1 and F2. F1 relates the volume of the pharyngeal cavity and how tightly the vocal tract is constricted, while F2 is related to the length of the oral cavity. The length and shape of the vocal tract determine the formant frequencies, resulting in the production of the different vowel sounds of the resonated speech signal. Wow! Formant tuning. The lowest two formants, F1 and F2, largely determine the vowel, while the remaining higher order formants are related to the quality or tone of consonant production, which we'll get into later. Notice the blue square next to hood, which we are currently exploring. What I want you to take away from this little lesson here is that the source filter theory describes the modification of the general sound produced at the larynx as it travels through the filters of the vocal tract and out the lips. The relative functions during this process are known as the source function, the transfer function, and the output function. The frequency F1 is related to the volume of the pharyngeal cavity, as well as to how tight the vocal tract is constricted. F2 frequency is related to the length of the oral cavity. Thank you, Carol Ferrand, for explaining that so well. Now you may be wondering, how are consonants produced? Well, let's dive into the consonant sound M and its creation. The nasal occlusive is produced with a lowered velum, allowing air to escape freely through the nose. Air escapes through the nose, but not through the mouth, as it is blocked by the lips or tongue. The oral cavity acts as a resonance chamber for the sound, obstructing the flow of air through the mouth. As this sound is voiced, The vocal cords vibrate while producing the sound. As a bilabial sound, the consonant is produced by creating a closure with both lips. Since the oral tract is closed, the effect is enhanced, giving rise to antiformants. No longer using the filter of the oral cavity as it is closed and relying on the resonation of the chamber of the nasal cavity. What I want you to take away from this here, folks, is that like stops, nasals involve a vocal tract constriction. But like vowels, nasals have a periodic glottal source. The amplitude produced by respiration and phonation is lower in nasals, such as than it is for vowels. This is partially due to the absorption of sound into the nasal membranes. Remember how we talked about density in relation to cavities in class? There we go. Since the oral tract is completely closed, this effect is enhanced, giving rise to antiformants. The vital information for each sound is contained in the formant transitions. This is what produces each specific sound we create in order to convey speech. Here are my resources for this